My name is Aniket Sharma. Let's start with the topic hydraulic turbine here. So turbine are basically hydraulic machines which convert the hydraulic energy into the mechanical energy, and this mechanical energy is further used in the running of the electricity generation, which is coupled to the shaft of the turbine here. So we can say that in a power plant we can use this mechanical energy for the generation of the electricity there. We can classify the hydraulic turbines on the different basis. As we can see that the first classification is based on the type of energy at the inlet here. So basically there are the two types of turbine here. First one is impulse turbine and second one is a reaction turbine. So if I am talking about the impulse turbine, in it all the available energy is converted into the kinetic energy or velocity head by passing through the nozzle at the end of the penstock, and which strikes to the guide plate which is fitted on the runner of the turbine. The example of the impulse turbine is a Pelton turbine. In Pelton turbine, there is a no role of the pressure head because all the turbine is open to the atmosphere and there is atmospheric pressure everywhere. But in the reaction turbine, runner is completely enclosed in the airtight casing and runner and casing is completely full of the water. Francis turbine is an example of the runner turbine here. So if I am talking about the second basis, the according to the direction of the flow. So there are the different bases of the turbine here, that is the tangential flow turbine, axial flow turbine, radial flow turbine, inward flow and outward flow radial turbine, and mixed flow turbine here. So if the water flows along the tangent of the runner, the turbine is known as a tangential flow turbine here. If the water flows in the radial direction to the runner, then the turbine is called the radial flow turbine. So there is a slight difference between the turbines, and if the water flows from outwards to the inward radially, the turbine is an inward radial turbine, and inwards to the outward, that is the outward radial turbine. And if the water flows through the runner along the direction parallel to the axis of the rotation of the runner, the turbine is known as the axial flow turbine here. Axial flow turbine. And in mixed flow turbine, we can say that if the water flows through the runner in the radial direction but leaves in the direction parallel to the axis of the rotation of the runner, the turbine is called the mixed flow turbine. According to the water head and the quality of the water available. So we can say that if there is an high head, then discharge will be low. So we classify the first basis on the high head and a small quantity of flow of the water. A small quantity of flow of the water means that is a small discharge here. And medium head and medium flow, that means the medium head requires the medium discharge and low head requires the large value of the discharge. Generally, if I am talking about the Pelton turbine, so Pelton turbine is basically a high head and low discharge turbine, and the Francis turbine and the Francis turbine is basically a medium head and medium discharge turbine, but the Kaplan turbine is known as a low head and high discharge turbine. Low head and the high discharge turbine. So we can classify these on the similar basis on the specific speed of the turbine. So what is the specific speed? The question arises here. So we can say that specific speed is the speed at which there is the unit value of head delivers the unit power here. At which the unit value of head delivers the unit power here. So on the basis of the specific speed of the turbine, we can classify the low specific speed turbine, that is less than 60 here, known as a Pelton turbine, and medium specific speed generally 60 to 400, that is the Francis turbine. Some books show that this value 400 is approximate to the 300 or 350. So in a high specific speed, that is the example of Kaplan turbine. That is the example of Kaplan turbine. That is the value having of specific speed is above 400 here. Above 400. So this is the classification based on the simple definition, that is the impulse turbine, reaction turbine, radial flow turbine, inward radial flow, outward radial flow, and similar basis having the axial flow turbine and mixed flow turbine and tangential flow turbine. Please go through it. It is a simple basic definition of the different types of turbine working here. Next here the impulse turbine and the reaction turbine. So we have the design basis of the impulse turbine, how the impulse turbine actually works here. So we can say that the water from the penstoke to the turbine via one or the more nozzle. Here the main parts, it consists the main parts of the turbine, the nozzle and the flow regulating arrangement here. And second one is the runner and bucket. And there is the rotation of the wheel due to the tangential flow created by the impact of jet here. And similarly in the reaction turbine, kinetic and pressure energy takes a role here, and whole turbine is enclosed in the airtight container filled with the water here, as we can see that in the figure also, this figure, and feeding of the water through the fixed blade in the casing. And next is a static pressure at the inlet greater than the outlet of the runner, and rotation due to the impulse reaction and due to the reduction of the pressure, so it is called the reaction turbine. So there is a two different types of pressure here. So the basic fundamental arises here, that what is the basic function of the velocity that injected to the vanes of the runner. So we can say that in the Pelton turbine there is an tangential flow runner used, that is the velocity is the same at the inlet and outlet. But in the case of the reaction turbine, there is a pressure energy as well as the kinetic energy here. So it is generally a different velocity at the inlet and outlet, that is the U1 and U2 in the reaction turbine, that is the Francis turbine here. So that is the basic function here of the impulse turbine and reaction turbine, and we can go through the all the functions of these turbines. So we have classified the basic differences here. First one is the all the potential energy is converted into the kinetic energy in the nozzle of the runner, and similarly in the reaction turbine only a portion of the fluid energy is transferred into the kinetic energy before entering to the turbine. As we can say that the flow regulation is possible without any loss, but the flow regulation is possible with loss. There is a loss in the reaction turbine. So as in the next, that is we can say unit is installed above the tail race, and unit is entirely submerged in the water below the tail race. Blades are only in the action when they are in the front of the nozzle in the impulse turbine, that is in the Pelton turbine, and in the reaction turbine the blades are in the action all at the time here. So this is all about the basic difference between the impulse turbine and reaction turbine, which is quite useful for the behavior, to study the behavior of these turbine. This is the picture of the Pelton turbine, which is generally we can see in the civil engineering or mechanical engineering labs. This is the Pelton turbine. There is a runner here. There is a runner here on which the cup shape guide vanes, cup shape vanes or blades are adjusted here. So the Pelton vane is the water tangential flow impulse turbine here, as we discussed before. So there is a velocity always is known as a tangential flow velocity, that is known as a TFR, tangential flow reaction turbine. That is also known as a TFR, that is tangential flow reaction turbine here. The velocity at the inlet outlet is same. It is invented by the Alan Pelton and the American engineer in 1870. This turbine is used for the high head. This turbine is used for the high head, and these are the main component of the Pelton turbine. That is, first one is a nozzle and a spare, and runner and the bucket. Casing here, casing takes a important here, and the braking jet here. So main component, this is the figure related to the main component here. As we can see that there is a Pelton wheel adjusted here, and this is the casing above it, and there is a sphere and the needle valve which strikes to the vanes of the turbine which is fitted on the runner, and there is an basically a nozzle here which strikes the water with the kinetic energy on the vanes. So this is basically the diagram related to the main component. So the amount of water is striking to the bucket, it controlled by the spare and the nozzle. We can see in this arrangement here the jet between to the on the bucket, and the spare is the conical needle which is operated either by the hand or wheel or automatically, actually depends upon the size of the unit here. So this is the all about the figure of the nozzle and the sphere which strikes to the vane of the turbine. This is the runner here on which the different types of vanes are fitted. It is a circular disc on the periphery which number of the bucket evenly placed here, and the shape of bucket is of the double hemispherical cup, and each bucket is divided into the splitter which divided the jet into the two parts. It is made of the cast iron and cast steel bronze and stainless steel, depends upon the head. Casing is basically used in the to prevent the splashing of the water. It is not a airtight container or airtightly closed. It is act as a safeguard and made of the cast iron or fabricated steel here. Last component of the turbine, Pelton turbine, is the braking jet, and the jet of the water used to stop the runner in short time, and strikes to at the back of the vane. Okay, so we have discussed all about the Pelton turbine. So there is a next turbine here that is known as the Francis turbine. So Francis turbine is a type of reaction turbine in which at the inlet we can say that the energy is available under the action of pressure, and the outlet there is an kinetic energy. So there are the two different types of energy uh, take a role here. So in this type of turbine they are the closely closed in the airtight container, airtight casing we can say, and runner and the casing is completely water full of the water. And if the water flows in the radial direction through the runner, this is known as all known as a radial flow turbine basically. So it is developed by the American engineer J. Bench Francis. That is an inverse reaction turbine, and it is suitable for the water head 10 to 650 meter, 10 to 650 meter, and the power output range is 10 megawatt to 7 megawatt. These are the some terms which I have to remind for just to create the difference between the turbines. And the speed range is the 83 to 1000 rpm, and it is the old Francis radial discharge at the outlet. It is the classification related to the old Francis turbine. So we have just discussed the main component here of the Francis turbine: the spiral casing, guide vanes, runner, governing mechanism, and the draft tube here. Draft tube here. Let's come with the main component here: the governing ring and the guide vane is spiral casing and runner and lower cost. So we have discussed the as we discussed the Pelton turbine. So In the case of, so as discussed in the case of the Francis turbine or in a reaction turbine, that the casing and the runner are always full of the water. The water from the penstoke enters to the casing, which is the spiral in the shape, in which the area of cross section of the casing goes on decreasing gradually. So as we can say that this is the basic diagram for the defining the main component of the Francis turbine. Here is the turbine shaft there. This is the turbine shaft here. And the casing basically so that the water may enter on the runner at the constant velocity throughout the circumference of the runner. Throughout the circumference of the runner here. This is the runner. And the casing is made of the concrete, cast iron or the plate of steel. Plate of steel here. So second main component is a guide vane and then is runner. So in a guide vane, basically it consists of a stationary circular wheel all around the runner of the turbine, and this stationary guide vanes are basically fixed on the guide mechanism. The guide vanes allow the water to strike the vanes fixed on the runner without the shock at the inlet. And it is also done by the suitable arrangement. The width of the between the two and adjacent vanes of the guide mechanism can be altered so that the amount of the water striking the runner can be varied. In the third component is the runner here. Third component is the runner here, then governing mechanism and the draft tube. So in a runner, it is a circular wheel on which the series of the radial curved vane are attached. As we can say that in the previous Francis turbine diagram, that is the different type of runner which is circular wheel on the which of the series of the radial curved vane. The surface of the vanes are made very smooth. The radial curved vane are the so shaped that the water enters and leave the runner without any shock. The runners are made of the cast steel and cast iron, stainless steel, and they are keyed to the shaft here. So next component here, that is the governing mechanism, is all about just to the govern or to the real function of the turbine, Francis turbine. And next is a guide. After governing mechanism, that is the draft tube. It is an important here. What is the function of the draft tube basically? We can see that there is a guide vane in the Francis turbine. Here, these are the vane attached in the diagram. So in the case of the draft tube here, we can say that the pressure at the exit of the runner of the Francis turbine is generally less than the atmospheric pressure. So the water at the exit cannot be directly discharged to the tail race. This is the important here. And the tube, a tube or the pipe of the gradual increasing area is used for the discharging the water from the exit of the turbine to the tail race here. Exit of the turbine to the tail race here. And this tube is increasing area is called the draft tube. So draft tube basically is used for the exit of the water of the turbine to the tail race. Different types of draft tube is used in the turbine, that is a moody type, rectangular end type or circular end type. So different type of draft tube is used to discharge the water to the tail race. So this is all about of the functioning. Thank you. For any query, contact me. Okay.